Ladies and gentlemen, I'm Yen-Luan Chen. I and the author Chin-Chih Chang are Associate Professor of Takming University of Taiwan. It's our pleasure to share our paper with you. The topics of our paper is determination of optimal successive work number for systems with random lead time, and the objective is to determine the optimal successive work number. And we consider a system with random lead time. These slides introduce preventive replacement. If we consider an operating system with a value time x has a distribution f of t, survival f bar of t, and value rate rt. Suppose that the j's working time yj with a distribution g of t, survival g bar of t, and we suppose the total j working time sj will be equal to y1 plus to yj with distribution g j, survival g bar j of t. A preventive replacement PR with code CPR is planned to perform at the number of n of working time. We can define the number of working time, and the time is from 0 to Sn. As this figure shows, please refer to it. This slide introduces imperfect maintenance. Before a CR, the system undergoes imperfect maintenance with value and experiences one of two types of values. 1. Type 1 value, which is repair or minor, with probability Q and is removed by minimum repair with code Cn. 2. Type 2 value, which is non-repairable or catastrophic with probability P and require a corrected replacement CR with a cost CCR. Please refer to these figures. This slide over the valuable our paper used. First, we can see that we set Z the waiting time until the first type 2 value. And we set the survival function f bar of t can be as this equation. The distribution function is as this equation. And the probability density function f of zt is as this equation. Now introduce the random lead time. A spare unit is ordered immediately upon the system installation, and the random lead time for delivering the spare system has a general distribution h of t and the survival h bar of t and the value rate ht, like this. We assume that if the random lead time finish before system replacement, either PR or CR. Then the replacement with stocking cost CH can be made immediately when the replacement stage takes place. Otherwise, the replacement with waiting cost CS must remain down until the spare unit is delivered. The mean cost rate J of N for the renewing cycle for the preventive replacement policy can be derived as this equation. Please refer to it. Now we offer the object of our paper is to minimize the mean cost rate as measure of policy by determining optimal replacement parameter N star. To minimize Jn, we can find N star, optimal N star must satisfy the equalities. Now we offer a numerical example to show our finding. Consider a value time x is Weber distribution like this, and working time y is exponential distribution like this equation. The lead time L is exponential distribution like this h of t. And we offered the parameter we use like these terms. We can find the resulting optimal solution in this paper and are compared until under the minimal repair probability Q, and we can find when Q increase, N star is non-decrease, and the mean cost rate is decreased. So we can draw the following observation. A finite and unique optimal PR number N star exists. And when the minimum repair probability Q increase, the optimal PR number N star non-decrease, and the minimum mean cost rate J of N star is decreased. This is the end of our paper, and thank you for your listening.